In this question, we are using the integral test to determine if this series converges or diverges. The generic term an, okay, here the generic term an is given by natural log of n over n. So we let the function f(x) needed for integral test is natural log of x over x. Just replace n by x. Now we need to show f is continuous on the interval. Look at this sum 2 to infinity. Okay, continuous, and it should be positive. F is positive on that interval and decreasing. All three things on 2 to infinity. Let's check. Natural log of x on positive interval 2 to infinity is continuous. If you graph, you get continuous graph, continuous, continuous, so the ratio is continuous, so this is good. Positive natural log of all the way 2 to infinity is positive, and x is, we are taking from 2 to infinity, positive, so the ratio is also positive. Now we need to show this function is decreasing. For we find the derivative using quotient rule and show the derivative is always less than 0 on that interval. That would prove the function is decreasing. Derivative less than 0 means the function is decreasing. But let's argue in this way. You can do, that's the most general method, but let me try to justify in this way. Natural log of x over x, which one grows faster? If you graph these two functions, when x is very big, the bottom gets bigger than natural log of x. When the bottom gets bigger than the top, that means the function is decreasing. Okay, so this is decreasing on 2 to infinity. Now this satisfies all three conditions needed for the integral test, and we find the improper integral from 2 to infinity of this function natural log of x over x dx. To evaluate this improper integral, limit t goes to infinity 2 to t. Let me write in this way. I know derivative of natural log of x is 1 over x, so let me write in this way, natural log of x 1 over x dx. Okay, how does this help? Now we make the u substitution. This is u and 1 over x derivative, so this is du. So it's like antiderivative of u du, and we know that's u is square over 2 using power rule. Okay, so that this is, let me go down, limit t goes to infinity, it's antiderivative of u du, so u is square over 2, so natural log of x square over 2, and we want to evaluate from 2 to t. Okay, so limit, this 2 can be pulled all the way outside, 1/2, limit t goes to infinity, upper limit replace x by t, so natural log of t quantity squared minus lower limit natural log of 2 squared. This is a fixed number. When t goes to infinity, when t is very, very big, natural log of t is infinity, very big. Infinity is square, even bigger, so the whole thing is infinity. That means this improper integral diverges. In turn, this series diverges.